Hello, I'm Bianca.
And I'm Paloma, and you are listening to The Climate Press.
A podcast where we aim to bring together climate science with public understanding and action.
Today on the show, we'll be traveling back in time to trace a history of climate science discovery into paths of acceptance and action.
We'll then talk about some of these transitions from knowledge into action, with a focus on how we as scientists communicate risk and how we as people understand risk and act on that understanding.
In this episode, we will be speaking with Kate Sambrook, a researcher at the Priestley International Center for Climate.
Thanks for joining us on the show, Kate.
Thank you for having me.
We thought we would start by asking you to guide us on this journey into space and time and tell us a bit about some of these key moments in history that have contributed to our current knowledge of climate science.
Sure, so like most history, this one begins quite far back. It actually starts in the late 1800s, if not early. And the first sort of pivotal discovery was by an Irish physicist called John Tyndall, who was the first to show that water vapour and other gases can create what we understand as the greenhouse gas effect, and what we call that today. But what was really interesting by looking into the history of climate change, it's actually questioned in recent years whether John Tyndall was the first to discover this.
Oh.
Because a lot of the key discoveries are by males, and there seem to be no women mentioned until recently.
Excuse me? What? That's crazy.
So actually a woman called Eunice Newton-Foote was mentioned.
Nice.
And after looking into this, John Tyndall is often credited with the discovery of the absorption of heat by carbon dioxide and water vapour, which obviously underpins our understanding of it today. But yet it's become very apparent in recent years that it was actually Eunice Foote who was the first person to notice the ability of CO2 and water vapour to absorb heat and to actually make the direct link between the variability of these gases in the atmosphere and how they link to climate change.
Interesting. Yeah.
Yes, and this was recently found in 2014. So this led me to why wasn't she recognised that she found this in 1856, which was 5 years prior to John Tyndall.
Mm-hmm.
So the question sort of arises, did people in that time recognise the significance of her findings? Was it a significantly new idea at the time because a lot of people were looking at this? Or was it her status as a woman and as an amateur scientist that made it so she went a bit unknown? So there's questions sort of around it that still haven't been answered today, which is really interesting. So obviously there was a very pivotal moment in science and for climate change. The next sort of pivotal moment in history is by a Swedish chemist in 1896 called Svante Arrhenius, who actually had the idea that burning fossil fuels such as coal, thus adding carbon dioxide into the Earth's atmosphere, would actually increase the planet's temperature. Again, the so-called greenhouse gas effect, so sort of building on the work that had come before, and actually estimated what the warming could be if we doubled CO2. Which, again, for its time, it is very notable. And then in 1938, so a few years later, Guy Callender, who was actually an English steam engineer and amateur scientist, so just very interested in climate change, but obviously didn't really have the background, but just used his interest to sort of motivate him to look at the problem. Used many global measurements that showed temperature rise over the 1800s. And this was the first time that someone had discovered the actual warming of the planet.
Okay.
So sort of documented on paper like what we were doing as humans, and what obviously natural cycles were contributing to warming at that time. And this really follows on to Charles Keeling, who in 1958 used measurements of the atmosphere carbon dioxide at Mauna Loa in Hawaii to show that CO2 concentrations were increasing.
Okay.
And this was later on linked to temperature rise, which is shown by the hockey stick graph that shows temperature rise is very...
And it's called the hockey stick because it has that shape in the graph.
Yes.
Yeah. Okay.
So if you imagine a hockey stick with the curved end at one end to the left, say, if you hold the hockey stick to an angle, it would obviously have this sort of increasing effect. So yeah, if you can imagine that, that's what sort of temperature has done. That's done over time, and carries on to increase into the future. So there has been a lot of key discoveries, as I've obviously mentioned. So these are sort of few and far between, you could say, but it was really like the 1970s, 80s where environmentalism started to rise and public doubts about the benefits of any human activity really started to increase. So curiosity turned into anxious concern, and people really started to notice if we did warm the planet anymore, or what the warming had done up to now, what these impacts actually were. So the rising sea level was a big concern and still is today.
Yeah.
And the melting of the glaciers and ice sheets.
Right.
That's what first comes to mind when you speak to people. So the momentum for research was really starting to increase in these times.
And when you say kind of this curiosity towards like an anxious concern, is that like we can draw that from the narratives that were used, or like that type of language that people started to utilize, or why do we have that kind of sense of the 70s and 80s in this like movement?
Yeah, I think it was just that people started to build up these ideas that had come before and started to translate them into impacts.
Yeah.
And maybe people really started to feel the effects at this time as well. So what we talk about today and what we talk about as extreme events, so things that are sort of interconnected, started to be unveiled as an impact of this temperature increase. So I think this sparked a lot of concern in this time. Research was being published, so it was in the public eye, and I think people just started to really trust in maybe what they were seeing, or because of the volume of research that was coming out at that time, because I think people really started to engage and become really concerned with what was happening around them.
Along this timeline, is there an example of how the scientific community brought this knowledge together and made it more accessible?
I think when the IPCC was formed in 1988.
But what is the IPCC?
The IPCC is the Intergovernmental Panel on Climate Change.
Representatives from countries that were appointed by each government. So these were scientists from various backgrounds coming together to understand not only historical climate change, but also how this historical climate change and what natural and human activity has done, and how this translates into our future. So I think the bringing together and forming this bond over one concern was a pivotal moment. And obviously a few years later they started to bring out out reports that were released and documented again the temperature increases so far, and they really started to think about what's to blame and started to explain how volcanic activity and solar activity, so the what we call as natural components, how they contributed, but also how us as humans were contributing by burning fossil fuels, and how much of that portion was due to our actions and not just the natural ones. So that came across in the 1990s, and I think that was sort of where it all began as a concern for many.
Do you think that every country or all the countries are equally represented in the IPCC or the Paris Agreement?
That is a good question. I don't think so. I think it's got better. I think with the Paris Agreement, there is this notion of including the small island states, or SIDS as they're known. But I still think there's a very large dominance of white males, developed countries that seem to be very, very heavily represented and are either leaders of the chapters or are very high up in their influence of what's written. I think they do try and represent as much as possible, but I think there is a gap and that needs to be addressed. And I think it's the argument again, which obviously came out in the Kyoto Protocol, was...
But what is the Kyoto Protocol?
The Kyoto Protocol is an international agreement signed in 1997 and linked to the United Nations Framework Convention on Climate Change. It commits its parties by setting internationally binding emission reduction targets.
We're asking developed nations to reduce their fossil fuels, but also for developing nations to develop. They can't really do the same, or we need to give them the ideas, the resources, the opportunities to create these sustainable ways of life by using renewables or using different methods to transport or heat their homes. So I think we do have that power as developed nations, and I do think we need to make sure we help as much as possible.
And even leading by example, I think
absolutely.
A lot of it.
Kate, why do you think it's so difficult to make climate science more relatable and to communicate these risks associated with climate change?
Yeah, I think it's just because it's quite a slow response. So what we've done in the past, it's not an instant problem that we see. It's very gradual, and obviously the use of the term global warming is quite confusing as well. So people think every year we're going to get more heat waves, and we might do, but we have to understand as well and really get across that we'll have those cold years too, and it's all that sort of goes around in the media or in research that can be quite confusing. We do all this research about the impacts and what we have to do to meet our targets for carbon emission reduction, and I do feel as a researcher that there is a lot more we can be doing to try and inject some momentum into this, because it's a huge problem that, quoting the IPCC, that we need to tackle now.
So Kate wrote a very interesting article that was published in March in The Conversation, and she talked about how extreme weather impact the UK and what kind of extreme events would we expect if greenhouse gas emissions keep increasing. Can you please tell us why you decided to write this article and how easy it is for researchers to share the articles like the one you wrote?
So this piece largely came from my work on the food industry in the UK, so food production and how this would be impacted by climate change. So the work I did on this piece, which was for the Climate Coalition, which is an umbrella organisation for over 100 charities in the UK. So I basically provided a scientific chapter on how extreme weather in the UK would impact food production. So that was flooding in the UK, but also droughts, how drying could impact our production, and also increasing temperatures and heat waves. So yes, I was approached by our communication officer on campus and was asked by a representative of the conversation to basically bulk out the findings on extreme weather and what that meant for the UK. And yeah, this was a really easy process. So the communications between both representatives was really fruitful, and they made it very, very easy for me to upload my draft. And after a few edits, it was approved and it was published within a week.
Wow.
Which is really quick, obviously, compared to journal papers. So yeah, and it got a lot of response. A lot of people were engaged with it. So yeah, I found the experience really good, and I definitely recommend to other researchers who want to try writing their results in a different way. So yeah, it's another way of communicating. I think that's coming back to what you said, Bianca, about the importance of communication. Like trying all these different streams is really helpful as well. An opportune thing to do, and a practice that everyone should think about doing.
That's great. Thanks, Kate.
You're welcome.
Thank you very much,
Yeah.
Kate. The great funky song that you've heard on this episode was written by Andrew Wilson from the Leeds College of Music. The chill song, as well as the intro and outro songs, were written by Marcos Arribas and Paloma Trascasa. On the next episode of the Climate Press, we have Astrid Kaus from the Centre for Decision Research at the University of Leeds.
Astrid will be sharing insights into some of the challenges about communicating climate risks and how we as people understand those risks.
Stay tuned for upcoming episodes and follow us on Twitter using @theclimatepress.
Please visit our website, theclimatepress.com.
See you soon! And remember, make love, not CO2.